Hello guys, and welcome to another episode of Synapsewerx Agentic AI. In this episode, I'm going to show you how we can use machine learning and traditional AI in order to create a real-time prediction workflow. Let me ask you a question first. Why do we need real-time when predicting events? Obviously, I'm asking in the context of an enterprise organization. Let me give you an analogy first. Imagine that you are wearing a blindfold and I ask you to cross a very busy street. And the information that I'm going to give you about that street, about the cars that are crossing the street, is 10 minutes old. How would you feel? Would you be safe crossing the street with information that is 10 minutes old? What if I tell you, you know what? The best I can do is 2 minutes. I can give you information about this street that is 2 minutes old. How would you feel if I tell you it's 10 seconds old? What if I tell you it is 2 seconds old? As you can see, there are situations where data is super important and we need to know that in almost real time, otherwise the consequences can be big. Well, in the context of an enterprise, the same applies. What I'm going to show you here is a business operational state. So it is information about that is, events that are flowing inside an organization. The demo that I'm going to use in order to tell you the importance of using prediction, high accurate prediction in a business workflow, for this I'm going to use a relatable topic that is customer attrition. Why? Well, most organizations obviously don't want to lose their own customers and see them going into the competitor. What I'm going to show you here is just a quick visualization of what we are going to do as part of this demonstration. Any organization will have a lot of information about customers because the goal is to understand customer attrition. We are going to be getting information from CRMs. We are going to get information from an ITSM, potentially what are the tickets, the service requests that customers have raised in the past 30 days. We are going to get information from an e-commerce. When was the last time a customer logged into the system? And all of this information is going to be flowing, and all of this information is going to be changing almost in real time. The challenge here is to be able to capture that information, those events that are happening, and integrate them with something that is going to give us intelligence. This is something that we have discussed in previous videos. This is what I believe is and most exists within every modern organization, and that is an in-house machine learning models catalog. I'm not talking about LLMs. I'm talking about small models that were trained in-house with customer data, with proprietary data. They don't need to know anything about the world knowledge. They only need to know the right information so that they can have high levels of accuracy. Accuracy to do what? Well, things like prediction, ranking, recommendation, anomaly detection, etc. And because when we train these machine learning models, they end up being small, and in most cases they are stateless. Well, we can deploy them within the firewall of the premises of an organization, whether it is on-premise or in cloud within their own firewalls. For example, we can use something like Kubernetes in order to be able to scale out or scale in the use of these machine learning models. We can provide the right level of security. We can provide the right level of accessibility, potentially through REST APIs, so that we can make use of those very high accurate predictions, models that were pre-trained for this organization, that understand the data, understand the customers for this organization, and understand that when something like this occurs, well, it is going to provide a very accurate response about the likelihood, the probability, whether a customer, an end customer, is going to churn or not. The question is, where do we get these machine learning models from? As I said, they are not off the shelf. They are not things that we can just get from any vendor, because they need to be customized for every single organization. And for this, we have been talking in previous videos about the important value of traditional AI. I'm talking about traditional data science that starts from understanding a business problem, capturing the right data that describes the problem, and understanding what variables are correlated to the problem that could potentially be causing the problem, so that we can use those variables and that data to train a model. And then once we have the model, more importantly, we can use it to do very intelligent decisions, such as in this case, when we analyze that there is a customer that is likely, with high probability to churn, what we are going to do as part of this demonstration that I'm going to show you in a minute is to create a task, and we are going to assign it with a representative so that they can do something before that end user leaves in favor to the competition. So as you can see, in the next demonstration, we are going to start from that traditional AI concept. I'm going to show you how is that with data science, we can describe that problem using custom data. And once we have this data, how is that we can create and get to the right correlation of variables that will ultimately give us that very, very accurate machine learning model that then we can use in order to create that AI inferencing in real time. Let's go to it. Okay, well, let's first start by understanding the problem and understanding the severity of the problem. In this case, the problem is that we believe there is customer attrition. How bad is it? Well, let's have a look at it. In this case, we are going to use our own data in order to visualize the customer attrition in the past 18 months. As we can see, from April 2023 to around August 2024, the customer attrition was quite stable. It was around just over 2%. It was coming in and up and down, but not too much. It was quite stable. But then something happened around August 2024 because there was a big increase in customer attrition. Maybe there was something trying to put in place during at the end of the year, or maybe it was just seasonality. Maybe it was just the end of the calendar year. Maybe it was Christmas season that ensured that a lot of customers did not churn, because we can see very clearly that from January 2025 onwards to April 2025, there is a huge increase in customer attrition. This is big. Like, we can see that probably this is around 15%. If this trend continues, imagine what is going to be of this business in 6 months. Okay, so that's pretty bad, right? The next step is obviously to perform that exploratory data analysis. And for that, normally what we do is to take a sample. We want to take a sample of customers that have churned and customers that have not churned. In this case, just around over 2,000 customers. These are customers that ultimately have gone to the competition. They have churned. And these are around just under 3,000 customers that have not churned. What we don't know at this point in time is what is causing this attrition. What are the variables that are causing this attrition? Because we need those so that we can create the machine learning model. Normally, the next step at this point in time is to do a lot of analysis, to start plotting, to start analyzing, slicing and dicing the data, to come up with some visualization that ultimately is going to give us a representation of what is going on. Like in this case, this is a heat map of the correlation of some of the variables that are creating the highest correlation for the customer attrition. As we can see, there are just a few of them. We have filtered out many into just days since the last login, high correlation, also the number of logins in the last 7 days, the number of support tickets that have been raised in the last 30 days, and then subscription tenure in months, etc. So once we have come down to this number of variables, then we can start thinking about training a machine learning model. So in this case, we are going to be using a random forest classifier with just around 100 decision trees. We are going to start pushing the data that we took from the sample so that we can create a very accurate machine learning model. We are going to save it. And then this is the machine learning model that ultimately we can start deploying into Kubernetes, and we can start scaling out as needed. So now this is the part of the actual demonstration of the flow. We don't want that machine learning model only for analytics and reporting. We want that machine learning model to be used at runtime, so that at any point in time, the quickest we can learn that a customer is with a high probability of attrition, we want to take an action. And the action is going to be to create a Salesforce task and assign that to a representative so that they can do something to ensure that they don't lose that customer. So in this case, let's just run the demonstration. I am setting that threshold to 80%. If we are finding a customer with a probability higher than 80%, we are going to create that Salesforce ticket. So every time that we see one of these, as you can see, every time that we go over the threshold of 80%, we can see that there was a Salesforce task. Basically, we are ultimately making an action, an insightful action, to know that there is a high probability that this customer is about to churn. How probable? Well, this is the level of probability. Let's actually go into Salesforce to start seeing. Let's analyze the customer ID 1325 and 1160. Okay, now we are in Salesforce. Let's analyze the last two that we just mentioned. Customer 1325. We saw that it was high. How high? Well, it was 94% with probability of churn. We created this task. We assigned it to the representative. The customer 1325 has been predicted to be at risk of attrition. Please follow up. The reason? Customer predicted at high churn risk, 94%, has not logged in the last 27 days. Let's analyze another one, the 1160. Customer 1160 has been predicted to be at risk of attrition. Please follow up. Reason? Customer predicted at high churn risk, 90%, has not logged in for 16 days, and only logged in one time in the last 7 days, and has raised 3 support tickets recently. Again, what happens if we are leaving these customers who are ultimately at high probability of churning without doing any action? Well, most likely they are going to go. And on the other hand, we can do something. We can do something before that happens. We can even go further in this analysis and understand when is that likely to happen. When? How long do we have before that customer leaves the organization based on probability? There are a lot of things we can do. And as I just showed you, everything comes down to data, to that customer data, to that proprietary data that ultimately is so valuable and can be used to create super highly accurate machine learning models that can be blended together with an end-to-end automation business flow in order to make very, very accurate decisions based on information that is changing in real time. I hope you found this demo useful. Thank you.